Thank you so much, and thanks for the invitation, and thanks for having me. So I'm head of architecture with Lab. We are a consultancy company based in Germany, and I do architecture consulting. We generally do consulting that actually has an impact, so we have a few very senior people who can do several different things in your projects and help you to succeed with your projects. I do a stream, so I'm going to do 2 streams from this conference. I wrote a few books. I do talks, as you can see here. I do consulting. And but the question, why this talk? Well, and that's a good question because agility is actually a development model, and software architecture is more or less the structures of software, but we'll dive into more details later on. So my claim is that they actually require the same skills. So as a person, if you do architecture to some degree, you will have to use the same skills that you would also use as someone who is interested in agility and is working as an agile coach. I consider myself an architecture consultant, so I don't really do architecture myself. It's rather that I give feedback and try to give hints about how you can improve your architecture and how you can make that better. And it is my strong belief that these 2 things actually require similar skills. The reason why this might be somewhat of a contradiction is because agility is about embracing change. That's, I think, the foundation of it. And a good symbol for this is the feedback loop, where you get some feedback, some changes, and you try to incorporate that into your system and in your project. And architecture, I think it still says it's somewhat stable. And there is a definition of architecture that actually underlines that says architecture are the decisions that are hard to change. So by definition, they are stable because they are hard to change. So for that reason, architecture seems to be something that is stable, and therefore there is a contradiction here, right? Because on the one hand, we have embraced change, on the other hand, we have stability, and there is somewhat of a contradiction. I'm not sure whether that's actually true, but I will dive into that also later. But the point that I really want to make is, what is it about the people? So the people who work on agility, which are, for example, agile coaches, but I mean basically everyone who works in an agile environment, and architects, are they somehow comparable to one another? And I wrote an essay for the Agile Meets Architecture conference, and I thought I would have been done with the talk more or less. Turns out I wasn't really, because it turned out that the article is quite different from what I'm going to present here. But there were a few hypotheses that I talked about in that article. And the first hypothesis is, I believe that architecture is sort of an implementation of agility. So let's go back to this diagram. So we have this feedback loop on the one side, and we have feedbacks on several different levels. So there is the sprint where we develop some software, we get some feedback from ideally some customers, some users, we incorporate that into our planning, we plan for new features, and we change our path in terms of what we are going to implement. There are retros which are more concerned with how do we work, what's the interaction like, how does that work? But there are also tests, which is a purely technical thing, where I put out my code and try to figure out whether it's actually correct and it behaves correctly. But that's also feedback, right? If I get a red bar in my test, it means that I should rather change my code. So this is all about change, right? So I get some feedback that says, okay, this is not the feature I should have implemented, but this feature is very, very valuable. So let's implement this in the next sprint. We are lacking in terms of collaboration, so let's do this to improve that. You have some problem in your code, so try to change your code. And of course, there is a lot of reprioritization where we say, okay, this is not really that important anymore. Let's rather focus on that. And this all gives, applies pressure, or it's an input to architecture. So I'm not even sure how architecture could be stable, because there is this changing environment that agility gives us. And for that reason, when someone says this is the architecture, the what that means to me is, well, that's just a snapshot. That's just the most recent changed version of your architecture. And if I ask you about the architecture next week, chances are it has been changed, or if it hasn't been changed, probably something is wrong. So therefore, I would believe that architecture is just sort of a snapshot, and it is something that is actually visible if you look more closely. So for example, there are the architecture decision records, and architecture decision records actually are by definition something that implements change. So architecture decision records, well, they are used to document some architectural decision. So you have some decision. We are going to use that technology. And there is a status, so it might be something that you're still debating or something that you have already implemented. There is a context with all the forces that led you to that decision. Here the decision is spelled out, and here are the consequences. And I think it's a very valuable format that is often applied. It's originally invented by Michael Nygaard, who also gave us quite a few other good tools. And what he said about this idea is that they had several clients who were stabilizing their current systems, and they were also looking forward to a larger re-architecture in the not too distant future. So therefore, they wrote down the intentions to make sure that changes in the future wouldn't be that hard. So they actually wrote down the reasoning that said, okay, this is the decision, these are the reasons why we made them, which is a preparation to revise that decision and come to a different one afterwards. So therefore, architecture decision records, by definition or by intention, are something that are meant to explain architecture in a way that it can be changed later on. So this is, in my opinion, clearly an implementation of agility in a way. Also, I would argue that if I look at architecture generally, well, it changes, and the forces that lead to the change are we learn more stuff about the domain. So even if the domain is stable, it's still that we have a limited understanding about the domain. And learning is something that you can't make it faster, and it's also something that just happens. There is no way to avoid it. So therefore, if I learn new facts, if I discover, oh, this really works that way, chances are that it also influences the architecture. Obviously, requirements change. That's something that happens all the time, and this is, again, agility. And then there is also different ideas about architecture, right? There are new concepts about architecture, new ideas, new tools, domain-driven design, microservices. There are even these sort of fashion that come and go about architecture. So all of that influences the architecture and make the architecture change. So therefore, it is something that changes, and agility is one of the drivers for these changes. I would even argue, I mean, if I look at some architecture about some system, oftentimes there's a lot to be improved, and that's sort of my view on the world, because I'm an architecture consultant, so I'm not asked to look at systems that are well architectured, but rather I'm asked to look at systems that have some room for improvement. Now the question is, why is there room for improvement? And I think the reason is because we are not changing the architecture once we actually need to. And there are good reasons for that. Maybe it's just that we don't have the resources, but sometimes it's just a neglect of changes that needed to be done. So therefore, you should be prepared to change the architecture. If you say, okay, this is the architecture that's going to be stable, and we made these decisions, and this is what it is, well, I think you have a bias to stay with the architecture and not change it once you actually need to change it, and that makes that problem even worse. So therefore, you should embrace change, and there you go, right? It's the same principle. I did a full talk about that, how if you try to make your architecture future-proof, that is something that people want from me. They want to have some statement that says, this is future-proof. This is something that we can use. It's not going to break in the future. And while I understand that this is the point, The problem is that this gives us a bias to say, okay, this is something that should be stable. Because if we now change this stuff, it's not future-proof, so therefore we failed. And that's a bias that is, I think, a problem, and that is why I did that talk. By the way, there is often some concept that says, well, we are so special, right? We are software, we are doing software. Software changes so frequently, and therefore it's all very different from other engineering disciplines. And I was about to write a blog post about what would happen if we built bridges the way that we build software, and I didn't, because I remembered that Hillel Wayne did something very smart. He interviewed crossovers, so people who are now software engineers and used to do engineering in other fields. And the question that he wanted to answer is whether we are actually doing engineering. And sort of the short answer is yes. The long answer is there are 4 blog posts about that, and also I did a stream with him about that subject for an hour. But one thing that I want to emphasize in this talk is that all engineering is iterative. So it's not like we are the only ones doing iterations. It's just that we are living in an environment where iterations are really, really cheap, right? So I can press a button somewhere, a continuous delivery pipeline takes my code, compiles it, puts it into production. I'm not even sure what the cost of that is. Might be a few euros, I don't know. If architecture is engineering, it should be iterative too. And just to prove to you that engineering is iterative, also other engineering, I want to show you the Porsche 959, which is one of the dream cars of the 80s. And there is one in the Porsche Museum in Stuttgart. And right next to it, there is a prototype. And I thought this prototype was quite interesting because if you look at it, there is, well, this is wood, I believe. And in there is a Porsche 911, I think. So it's sort of a Frankenstein car in a way. And if you look at the back, there is even some things that are made out of, I don't know, GFK or something. It's sort of interesting. But if you think about it, obviously there's a prototype. And obviously there are other prototypes. So obviously there is some kind of iterations in place because you would build that prototype to prove something. I'm not sure what they proved with this one. Maybe it's about aerodynamics. I have no idea. And then they built the real car. And obviously this iteration is expensive, right? Because they took a Porsche 911, which is not that cheap, and did something to it, which is also probably not cheap. But still, they did iterations. And as I said, I did an episode with Hillel about that, where we talked about that, and it's clear, I believe, that all engineering, not just software architecture and software engineering, is actually something where you work in iterations. Second hypothesis is architecture and agility are all actually about people. So there is something that I want to call the traditional architect, maybe something where, how we perceived architects in the distant past. And usually we would probably say that this is the most experienced person on the team. And I think that's already hard because, for every detail, I do understand a few things about specific topics like domain-driven design. I don't really understand a lot of other different topics like front-end architecture. So I'm certainly not, I would never be the most experienced person for every detail in my team, and also not for every technology, because there is just a focus, and obviously it's unrealistic to be the senior person in everything. And in the traditional understanding, I would be supposed to do all important decisions, which actually puts enormous pressure on me as an architect, which is the reason why I'm not sure why I would ever do that, why I would want to have that role. Because then I'm the person who makes all the mistakes, right, by myself, and that doesn't make a lot of sense. It's also quite sad if I'm the most experienced person concerning everything. So therefore, you should use the technical expertise of the team and grow the team, because that's your only chance to actually get enough technical capacity in your project to make sure that it's actually successful. And the same is true for understanding the system. I mean, as an architect, I need to understand the system. Now, sort of by definitions, the systems that we are building are too large for one person. That's why we build them in teams, obviously, and that's one of the core problems that we have. So if I really want to understand the system in every detail, I need to use the expertise of the team, and I believe that each team member will understand some part of the system, right? So maybe that person over here understands that part, and they understand this part, and so on and so on. So it's quite logical to talk to them and ask them about their view on whatever it is that I want to do to the system, or whatever understanding I need to reason about the system and make some decisions. Then lastly, there is the idea that the architect would define the architecture, so I would make all the relevant decisions, which, as I said, doesn't make a lot of sense, and then I would enforce it. And I find that quite interesting. So to make sensible decisions, I need to understand what the team actually is struggling with and what the problems is. And I need to have feedback about those decisions, because I perceive those people in the team as experts for specific details of the system, and with experts who have a specific view on the system. And I need to communicate my decision. I would not enforce it. That doesn't make a lot of sense. Actually, I'm seeking feedback, right? So therefore, it is something that is still in the air. Is that really the final decision? It's just my plan. I need to get some feedback and see whether it's actually a good plan and have that conversation about the decision. Then I will use the expertise of the full team, which is, I think, a good thing. And then I will probably have better decisions. And also the chances are that the team actually executes the decision because they were part of the decision process. It's not something where we tell them, okay, do that, and they don't understand why they would ever do that. It's their plan, and they have part in that plan. So we won't have that ivory tower that architects should be afraid of. So that means I would moderate, I would listen, I would try to convince people, I wouldn't enforce it, I would try to make my expertise usable, my specialty and specific things, which I believe is probably a general rule for managing self-organization, like making sure that you get buy-in, making sure that you get all the feedback, and so on. And there is one thing that I sort of, when I make a decision or when there is a decision to be made somewhere, I think it actually has two levels. So there is the subject matter itself. So we are going to use that technology. And there is the question, how is that decision made? I can make it by myself. I can try to do it together with the team. And I could now make a decision to say, okay, we're using that technology, I don't know, Angular, whatever. And then I would probably hurt the autonomy and the buy-in of the team. And then the question is it worth it? So there are quite a few front-end technologies for that matter, right? There is Angular, there's React, and so on and so on. So is the difference between two technologies really that big that I want to push it through? Is that going to threaten my project, the success of my project? Is that probably something that I want to compromise on? Are there some things that we can formulate as a requirement that needs to be matched, and as long as that requirement is matched, we can live with any technology? If we just push it through, we will probably have a problem with the team and how the team works later on. And if that happens frequently, then the question would be what's wrong with the interaction between the architect and the team. So this is something that I think might be comparable. I mean, I spent quite a few slides on the architect role because that's what I'm familiar with. If I look at an agile coach, in a way, their goal is to make the team perform and create a cross-functional team. So they do have a different focus because they are only focused on the social interactions and the people, and they probably don't really understand software architecture. So they work on a different level, but it's very comparable, and I would at least argue that those two roles are natural allies, right? Because they're looking for the same thing, like a team that actually works and performs. And this is the reason why I think the skills are similar. Then there is the part about how architecture enables the autonomy that we are looking for in agility. So in agility, we want to have autonomy in the sense that a team should be able to somehow build something that provides some business value by themselves, which means they should be cross-functional, because chances are that you have to have different roles, different people, experts of different things, and have them all collaborate. And in a way, this is autonomous because the team would then do that by themselves. There are some technology decisions that can support autonomy. So if you have microservices, for example, they allow you to independently deploy each microservice. They also allow you to make independent technology decisions. So each of these parts, each of those Docker containers can be, the software in them can be written in Java, in Rust, whatever it is, and they can be deployed on their own. Which might translate in more autonomous teams. So there is an enabler here, right? We can now push the decision which technology to use to the teams, and when to deploy, we can also push that to the teams. Now the question becomes, what should those teams actually decide by themselves? And there is the idea of micro and macro architecture, which basically says we are going to delegate specific decisions. So there is some decision that is binding for our modules. In our example, it would be every team needs to provide a Docker container that's binding. So if you don't do that, you're out of luck, because we're going to run on the Kubernetes cluster that we have there. And the microarchitecture decision, well, that could be something that is different for all modules. So we could make a decision that says, okay, the technology that you use, it's a microarchitecture decision. So whether you're using Java or any other language, Rust, whatever it is, that's your decision. And that can be left to the teams or not. That depends on how you actually, what kind of freedom you give to the teams. In classic macroarchitecture, you would say, okay, there are basically technical decisions, as I explained. So we would say, okay, Kubernetes is a standard. We are going to use Kubernetes. The programming language is your thing. And we have a technical framework and a set of technical guardrails, which must be enforced, right? Because if we have that Kubernetes cluster that everyone runs on, and someone says, okay, we're going to build some serverless thing, well, it won't work. So therefore, we have to enforce that decision. And it won't work because we don't have the environment to run that. There is a different approach, and it's completely different towards macroarchitecture, which basically says, okay, here are some technical challenges. So there is scalability. We are a huge company. We have lots of users. So scalability is an issue. Your team needs to be prepared to meet the scalability goals that we have in our organization. We can solve that problem in different ways. So we can scale out, so we can have more instances. You can have more instances of your service. You can scale up, so you can have a large instance of your service. There are other things like graceful degradation, so you just switch off your service if the load is too high, because maybe your service isn't that important. Why would I give requirements if everyone just buys a specific product? Anyways, probably doesn't make a lot of sense, so then I can just switch it off. And in that document, I could include experts for these approaches. So I could say, okay, and here is the person that you can ask about scale out or scale up, which is basically a document that gives you some support. So if I had an architecture role in a company, this document would be very helpful. It says, these are your challenges, scalability. This is how you can potentially solve them, and here are some persons to talk to them. This all translates to autonomy. So more micro-level decisions mean more autonomy, which requires trust and also willingness to take responsibility. And this approach where I have the requirements, such as scalability, I actually trust the team to think for themselves, try to figure out what that actually means for them, and try to reach that overall goal. Which means I trust them that we all achieve that goal, and they must take the responsibility. They are not in a role where they can just do what is told to them. They have to figure out what their mission actually really is. So the architecture, in this case, clearly defines the autonomy. And and that's basically the point that I'm trying to make here. Next hypothesis is there is this problem of the illusion of control. And I think that's a problem that architecture and agility share. So let me tell you a story. So here is a system, and the idea for that system, to build that system, was to migrate it module by module. Okay. They weren't really sure whether this would work out, so they built a prototype, which was actually quite expensive. So this is the architecture decision that they made. Now, the project started, and they learned more about the domain. As I said, that's inevitable, right? It just happens because you're dealing with the domain now. And it turned out that the migration by modules, module by module, is not possible for some domain logic reason. Because they wanted to improve the support for business. So that was the goal, the competing goal, and it made it impossible to migrate step by step, module by module. And then there were other issues, and finally the project was cancelled, and it was officially considered a failure. You know, sometimes projects are cancelled and everyone says, yeah, but it was really a success. But in this case, it was really officially a failure. Now the question is, what is the takeaway? And I think this is quite embarrassing, right? Once you build a prototype, you build the first, and you figure out that it's possible to do what you're planning to do. You get the first reality check, and after a short period of time, it's absolutely clear that what you even prototype doesn't make any sense. And I don't want to be embarrassed, so I would probably do more research up front. So I would do another prototype, and I would be more restrictive in approving projects, because project that is cancelled after such short period of time, that's weird. And the reason why we would do that is because we think we can control such issues. Basically, there is the basic assumption that we weren't smart enough, we didn't really figure it all out. So next time we try to be smarter and we try to figure it all out. And that's the illusion of control that I'm talking about. The problem is, even if we had built that prototype, even if we had done that project, something else might make another architecture decision or that architecture decision obsolete. And we have to redo it anyways. So it's not a matter of, yeah, we are going to build that thing, we are going to have that idea, and it's going to stay forever. It's just that we learn about things, as I mentioned, and they change. However, I would have felt, so I wasn't really part of that project, I would have felt embarrassed too, and I think it's somewhat logical to say, okay, we need to be smarter about it. So the better approach would be to say, okay, we are going to build that architecture for the very first step, and let's see how far it takes us. And I'm not sure how you feel about it, but I feel scared about that, because it means that I know that it's going to take me so far, and there's this stuff that I don't know about yet that might be a huge problem, and that I, well, don't even know about it, so I don't really have an answer to that yet. So, and I think that's the reason why people really try to be very smart about the architecture instead of just doing the first iteration and doing the next. And I think we have a similar problem in agility, where we have, on the one hand, this agile approach that says, oh, okay, we're building the software in iterations. And on the other hand, we have this attempt to have the complete specification and planning, which works, seemingly at least, if you build a house. People who claim it works if you build a house haven't really built a house, but that's a different point, right? So also building houses, which we are doing for, I think, centuries, millennia, is still very, very hard and stressful for people who are trying to do that. And it turns out you can't plan anything, and I would argue that this should be obvious after your first project. So if you do a retrospective of your first project that you ever did, I think the conclusion will be, well, we thought it would work this way, we were really, really wrong, and we couldn't have anticipated that it would work completely differently, so we should be prepared for change. I think that's quite logical, but we still keep doing planning instead of iterations. And I think the reason for that is the illusion of control. And I can totally relate to that, saying, okay, we're going to do this, and we don't really have a plan that's going to take us until the end, and that is really thought through. That's scary, and it might even appear stupid to some people, but that's what we should probably be doing. So, conclusion. Well, as I said, architecture is the implementation of agility. So that's the first hypothesis. The second was that it's all about people and how they communicate and work together. Architecture can enable the autonomy that agility is looking for, and we have this problem of the illusion of control. There are a few links that I want to give to you. So first of all, there is the essay, which is really different from what I said here, at least in some points. We are looking for people who want to join us. This slide is in German, so I'm afraid we are looking for German speakers only, and I do apologize for that. If you have any further questions, you can schedule a virtual coffee with me, also tea or whatever you like. So we would do a Zoom call then, and it's up for you to provide your beverages. And finally, if you want to have the slides, you can send an email to this email address, or scan the QR code and download it there from the OneDrive. So that concludes my talk, and I understand that there might be questions somewhere.
First of all, thanks a lot for the talk.
Thank you. It's close to impossible to see the audience, so that's...
No worries, we have the questions here. And you actually spurred a lot of questions.
Oh.
First one, or most upvoted one. Is dictatorship necessary in certain architectural decisions?
Sorry, I didn't get that acoustically.
Okay, given that teams split into camps and facts don't convince the other side, is it sometimes necessary to have a dictatorship in certain architectural decisions?
Yeah. I mean, that's a good question that we could probably also ask about our societies, right? I mean, if we have a problem and rational arguments don't really convince people, what do we do? And is a dictatorship the way out? How shall I put it? I think that's a problem on the social level. Which means that sort of the consensus and the decision-making sort of broke down, right? That's the problem. And maybe pushing through things is then what is left to you. But I would try it in the environments that we work in. I would try to solve that social problems, and we have a greater variety of options, right? We can try to, in the most extreme case, we can just remove people from the team, which we can't really do in society. So therefore, yes, maybe that's what you need to do, but I would try to solve the social problem and try to work on that. And that is often neglected, right? Sometimes I have the impression that it's quite clear that we have a problem on that area, but we still talk about the rational thing, right? Which technology are we going to use? But it's quite clear that someone said, here, this is what we should be using, and I'm not open for any compromise, and I just shut down the discussion, and I'm not open to any arguments. Well, then I have a social problem, and arguing still about the technology, I'm not sure whether that's what you want to do then. And leads to the question, why do I emphasize on making collaborative decision-making? Because I think it's quite tempting to say, I'm the architect, I should know, so I'm going to make that decision. So I think the mistake that people, I think, are doing is that they lean towards pushing through decisions in cases where they don't need to. If that is your problem, if you are in a situation where you need to be more dictatorship-like, I would argue that's an uncommon thing. But maybe I'm wrong.
Okay, thank you very much. So, in quite a different take here is the next one. And this is about the quality attributes and decisions related to these. If we consider things like security, what does that mean for agile architecting and what's needed there?
At the end of the day, quality attributes are, in a way, requirements on the technical level, right? So, example would be security, so I have some specific requirements in that regard. There are functional requirements which say these features are needed, and then there are these quality requirements which are about technical properties like security and other things. So I don't really see how that is fundamentally different. And there are functional requirements as well as quality attributes that have a huge impact on architecture and that you need to be aware of, ideally at the start. The point that I'm trying to make is I'm not sure whether you can actually do that because you can't know everything at the start. It's learning, and learning is inevitable. You can't command people to learn faster. It's just not possible. So therefore, you might be missing some requirements, whether they are functional requirements or whether they are quality attributes, and then this is why we are working in iterations. And maybe stuff doesn't work out, so this is why we work in iterations. And sometimes we have these embarrassing things where we didn't understand something and it has a huge impact. But as I said, and that's what I was saying about this migration module by module, I'm not sure what other way there is. I mean, do you want to spend a year planning and then figure out that you still missed something? I would rather try to build software and figure it out. The other point is, I think that's also, maybe that's one of the points about that question. You shouldn't be intentionally stupid. So you shouldn't, and this is something that, that's one of the problems that I have with this Yagni approach. You ain't going to need it. So if someone comes to me and says, okay, I believe that we have a problem because security is quite important. The answer shouldn't be, you ain't going to need it, so we don't care about it. The answer should be, okay, tell me about it and let me figure it out so that I have some rough idea what's going on. So, and that's what I'm trying to say, right? I wouldn't be intentionally stupid and say, okay, I know there is this problem, this is a potential problem, I just ignore it. Instead, I would try to, but at the end of the day, it's risk management. I would try to figure out whether it's really something that is a huge risk for my project and is something that might sink the project. And then I would try to care about it with a high priority or maybe deprioritize.
Yeah, I very much like that approach.
Thank you.
And I hope it answered the question. If not, once again, it's very easily possible to grab Eberhard during lunch or during those 2 days. One final question for now.
We have actually a booth, so I'm going to be there tomorrow morning at least. Yeah.
Cool. Yeah, just meet him at the Swag Lab booth. Final question for now before we head off to lunch. What to do if no one wants to make decisions?
What to do if no one wants to make decisions? Yeah. Sadly, that's a good question because I experienced that once, and the approach that I tried was to say, okay, we are going to do X. If you don't think that X is the right decision, then please tell us until that deadline. and that got a response that basically said, I don't see how I can make that decision. So I wasn't able to force that person to make a decision. Well, I mean, it's just not possible, right? Because as soon as I take the keyboard and enter some code, I do tons of decisions about what I'm actually coding, which technology I'm using, how I'm tackling the problem, and then it won't work. And I think there is a social problem again here, because, I mean, in real life, outside work, people do make decisions, right? Why doesn't that work in that work environment? Why are they somehow not able to do that anymore there? And I mentioned that, right? So the Agile coach is probably your natural ally. Maybe they have some idea. And generally speaking, I think, psychology, these things, would be something that might be quite handy for people in our profession, because at the end of the day, it's a people's profession.
Thank you so much.
Thank you.
And your applause.